Hello, so we're starting again today, the same day as the same outfit. After a failed data recovery because the NAND was cracked, I already posted that video. I found an interesting case. Here is an iPhone 12 Pro board. The problem, well, I found it interesting because I had a similar case like this few days ago, and I posted on some Facebook group, and I got a lot of questions about the way I've diagnosed it. So this seems a bit similar. So I'm gonna roll the intro, and then I'm gonna tell you the story for about this board. Okay, so let's get the intro first. Okay, so we have this 12 Pro board. It comes from a phone that was actually plugged into a car charger, and the owner said that the charger caught on fire, and the phone that was connected to the charger and the tablet that was connected to the charger, they both died and didn't start anymore. So the phone went to a different repair shop. They replaced the battery, and with another battery started. So interesting enough is that it was not charging the moment we were plugging the charger into the phone. The phone just turned off, and then you have to remove the charging cable and power it back on using the button, and the phone worked normally. So first thing I did, I've split the boards, and I've seen that the charging IC, the Yancy, was actually almost exploded, so it was in a very rough shape. I've replaced the Yancy, and I've replaced also Kraken just to make sure it's fine. And now look what happens. Let me power on the power supply software, and here's an interesting thing. Get the microscope over here. Right, and let's try to power on the phone using the squid. I'm gonna connect the squid, and let me share with you the background of the computer. I think you see both the microscope, this camera, and the computer there. I'm gonna power on the power supply, so the output is on. We can see a blip there, like the NFC is drawing a bit of a current. And now if I try to prompt to boot using the button, the power button, it's following a normal boot pattern. It goes to 74 milliamps, then goes to 80, and look, it dies, it comes back up again, goes to 80, and it goes down again. So you see that pattern, right? It was the same pattern that I had on the other case that I didn't film, and this is how it's behaving. Remember, I've replaced Yancy and Kraken. Let's put the thermal cam and see if we can spot something using the thermal camera. Yeah, so we can see basically a normal, kind of a normal boot behavior. We can see here the logic EPROM getting hot, like the phone is about to start. We can see the CPU a bit warm. Again, these are not shorted, so this is normal. And then there's nothing out of the ordinary going on with the board. We can see also the Yancy a bit hot, and that's kind of it. So this is a normal behavior during a boot. Now, how could we go further with the investigation. The thing is that while Yancey was out, I have removed the I have checked all the pads under the Yancey, and all were measuring good. In the other case it didn't, but what should we do now? I think the best option for this one would be to investigate the signals on the I2C lines that go to the battery. Those I2C lines, I know from a previous case that if something goes wrong there, the phone could have this behavior. So I'm gonna turn off the power supply, and let's try to connect the oscilloscope to those pins. The easiest way to do it is to actually connect two wires here on the power supply connector. Let me get some tape to tape it down, and let's see if there's something wrong with the data communication on those lines. We know that the I2C protocol, the I2C lines are working on 1V8, I think, but we're gonna have a look at the schematic. I'm gonna put some flux here and some flux here. Alright, you can't see it. Now it's better. And let me grab two wires. I have one here. One line is clock and the other one is data, and that's the normal thing for a I2C communication. You have a clock line and a data line. Okay, hope it sticks good. Don't know if I properly solder it, but it seems okay. No, I don't like it. I'm gonna redo it because it's a bit too high, and I'm afraid it's gonna touch something on the connector, and then we're gonna get false readings. Yeah, this is better. Okay, and let's do the one on the other side too. Let's see how this comes in handy. I think this is okay. Let me get another wire. And see how it works here. Okay, this is perfect. Let's clean the connector a bit. Okay. Okay. Okay, I'm gonna need to pause this a bit. Right, let's blow it off. Perfect. And now let's connect this here. Okay, it's perfect. We need to look on the schematic and see which one is clock, which one is data. Okay, so we know the outside one is clock. So this is gonna be a clock line. And the other one will be data. Let me grab some leads from the oscilloscope. Power this on. So I'm gonna have channel 1 is gonna be clock. And that, I hope it's making a good connection. And channel 2 is gonna be data. And then the two remaining grounds, I'm gonna connect them to the supply ground. Alright, so I think I'm gonna have to move this camera. Alright, so we have a good look there. We can see two lines there. One is the clock line, one is the data line. I'm gonna power on the power supply. Let's see if we have another view, but we don't. And I'm gonna power on the phone using the power button. Okay, so you can see there the consumption. The power supply is on. So I'm gonna prompt the phone to boot. Okay, phone is on. And what we can see here is that we can see the data line at some point is gonna be pulled up. See, it's pulled up and now it's back down. And see, so there is no trace of communication. This is not how it's supposed to look. Let me put let's put another known working board so you can make an idea how this communication looks like. I think it's better that way. Let me get a board here. So we have here a donor board, which is known to be working. Let me power on the power supply again. So supply is on. I'm gonna prompt it to boot. Alright, so now it is booting. You can see I'm gonna try to grab a single shot. Here it is. You can see how it looks like. So we can see here the clock line, and we can see the data line, and it's constantly another one and another one. Let's move the trigger a bit to the left. Gonna do another one, another one, another one, another one, another one. So these are just single snapshots. Let me try to move this further. I don't think I can. So you can see the whole picture. No, you can't. Alright, gonna leave it like that. So this keeps communicating on those lines. What we noticed on the other board is that this data line was being pulled up, so the clock remained down. Let's go back to that board and have another look at it. Yeah, I'm gonna make this run. It's not gonna trigger unless there's activity on the trigger. Power on the power supply. Okay, and you saw that the moment I prompted to boot, the data line went up. And then it went back down. Again it went up, it's up now, and now it's down. in theory, when it starts, we should see both of the lines going up because they have pull up. We're gonna look at the schematic, and then while they're up, the communication is gonna pull them down while they communicate, but the lines should stay up with no communication. So obviously there's a problem here on these lines. So let's turn this off and let's have a little look on what's going on with those lines. In fact, I'm gonna leave this connected here. No, I'm not, because I'm gonna break them. Let me remove the oscilloscope probes. I'm gonna put them aside. Let me move back this camera because we're gonna need it, or not. Maybe we're not gonna need it. I'm gonna leave it like that for the moment, and let's have a look on the schematic. So schematic is really important. Let's see here. So here we have the battery connector. We see this clock line is going directly to Yancey, and the data line, sorry, I lost it, and the data line is going again to Yancey directly. Yeah, so judging by the name, it's an 1v8 line, right? And the other one, again, it's a 1v8 line. But we can also notice that while the data line goes directly to Yancey, we have the clock line. The clock line is also going to this U2470 chip. And if we look in the schematic, this is a level shifter. So what that means is that it has a 1v2 I2C communication on one side and a 1v8 I2C communication on the other side. So basically it helps interconnect devices that are speaking the I2C protocol in different voltage levels. So we have 1v2 and 1v8. While it's not that big of a difference, it's important to keep the levels as the chips need them. And you see they are being pulled up because we have these resistors here that are pulling up the lines. So the moment the power supply starts, the lines should be all pulled up. So what I'm gonna try now is, because we know that this one had a problem with Yancey, and I've already replaced it. Let me go back to the microscope. So Yancey was replaced. This one was replaced. Kraken was replaced. I'm gonna try to remove the U2470, it was, right? And see if maybe it got also shot during this one. Let me see, do I have the old one? So yeah, this is the old chip. You can see here it's all burned and cracked. So this was the original chip that was on this board. I replaced it with a good working one, and now I hope it was a really good and working one, because I haven't tested. It was from a donor board. Yeah, but let's see what's going on. I'm gonna remove U2470, and then we're gonna power up the phone and see how it's behaving. But again, it might be just a case of the Yancey that I've installed being defective. And again, I'm gonna switch it back. But first I want to look at this level shifter, because I had a case a few days ago with the same behavior, and this chip was dead. And I'm sorry I haven't filmed that. Okay, so the chip is out. I want to put it aside. Right, so in theory the phone should boot now without this chip. Of course it's gonna restart every 3 minutes because it's not gonna be able to do I2C communication with the battery and other stuff that are shared on that line. But yeah, let's see what happens. I'm blowing some air with the pump so it cools down. Alright, so let's take the power supply software again. And see what's going on. Let's see if it boots. If it doesn't boot, then I'm gonna try to replace the Yancy one more time. But if it does boot, it means that the chip was the culprit. So let me prompt to boot. Yes, and now we have a normal boot behavior. You see the phone is booting fine. It doesn't power cycle. Okay, so it seems that the chip is a bit of a weak spot, because it's the second one that happens to me to be burned. Let me see if I have one. Do I have one on this board? No. I think I have one here. Yeah, this is the one. Let me switch back to the microscope. Oh man, I'm so glad that this situation happened again, because I was quite sorry I didn't film the last one, because I find it a very, very interesting repair. And to be honest, I tried to replicate it, because I lost the old defective one and I couldn't find it anymore. It's very small, and I tried to replicate it, and I tried to burn one, but it didn't work. So I felt a little bad, and now today when I worked on this one, I said, oh wow, impossible. I hope it's making a good connection. I didn't have a look on the chip how it looked on the other side. Don't think it needs to be reballed. I'm just blowing air again to cool the board. Right, so I think it's cool enough. Let's also put a display on it. Okay, so we have display. We now come with the power. It's a bit difficult with my wires. Right. Right, so I think the power is connected fine. Looks good. Okay, and let's connect back the microscope. So we had channel 1, we had a clock. Just ignore that because it's noise due to the ground not being connected. You can't see it anyway. Alright, let me ground up the microscope. Okay, perfect. So, let's go like this. We have the microscope connected. Okay, like that. So you can see also the power supply. Power supply is connected. I'm gonna press the power button. We can see the NFC blip. Right, and let me try to prompt it to boot. Interesting. It's power cycling again. And again the data line is being pulled up and down. Did I connect the... Oh man, I think I got the bad chip. Let me get another one. I hope I'm not making any shorts here. Let me disconnect the display. Alright, let me try again. Prompt to boot. Prompt to boot. Yeah, and it's not working. We can see the data line blipping is being pulled up, then down. So the chip that I've installed, it might not be good. Let me get another board. Let me get another donor. Let's see if this has it. I'm gonna remove this one first. I'll take it to the microscope. Okay. And let's remove the chip. Alright, so chip is removed. Let me get another one from a different board. This one's a bit dirty here. Alright. Let's put it back here. I need a bit of wax. Okay. I think it's good. Let's cool it down. Alright, still a bit too warm, but we're gonna go with it like that. Let's power on the supply. And let's try to prompt to boot. No, I think it's not gonna work. So we have the same behavior. That's crazy. Can it be the Yancy? Maybe the one that I've installed was malfunctioning. I don't know. Let me prepare another one. And test with another one. I already have the board here. So let's get this board. Let me move the camera from the oscilloscope. So you can see what I'm doing. All right. Let's get this one off the board, rebolt, and installed on my board. Maybe it was the chip. I really don't know. Okay, so this is a bit annoying. I don't like it because it's in my way. All right. No, what's happening? Okay, and let's get this. Okay, perfect. Have some solder here. And the stencil. Where's the hole? It's like this. Okay. It's a bit difficult when I'm filming because I need to also look at the computer and see if you can see everything I see. And I also have to speak, which I usually don't speak even when I'm alone. But okay. Need to clean the stencil. Alright. Let's reflow this once more. Okay, perfect. Let's clean this a bit. Put this aside and remove the old chip. I'm gonna put some copper plate on the CPU so it doesn't get extremely warm. Okay, old one is out. Let's clean the pads. Alright, so pads are clean. Used a bit of alcohol just to get the old flux out. I'm gonna put some new flux. It's a bit too much. Put back the copper plate and let's get the new ENC. Okay. Let's try to stick it down. Okay, so the chip is soldered. I could see it bounce. Now let's try to cool that off and give it another try with a power up and see if it works. If it doesn't, then I'm a bit stuck, as I really don't know what the problem could be. But again, it's very interesting. Let me connect the power supply again. All right. So I've connected the squid. Let me share desktop also. I think you can barely see the graph there, but yeah, like that. I think it's better. And let me get a tweezer to prompt this to boot. Yeah, so we have a normal boot there. That's excellent. So it means that actually the I either damaged the Yancy when I moved it over, or there was something else. Let me move back the camera in front of the microscope, in front of the oscilloscope, so we can see how it comes. Oh, Jesus Christ. Sorry for that. Bit of technical issues with the camera equipment. All right. This is better. So let me connect back the clock line. So clock line comes here. I'm gonna see something weird on the oscilloscope because I haven't connected the grounds yet. But please ignore that. I'm gonna connect the data line. Alright. Fuck, it broke. I'm sorry for my kind words. So I have a problem with the wire on the connector. Let me switch back to the microscope and see what's going on. So my wire broke here. Let's try to solder it back. Need a bit of flux. And let's see if we can do it with this ginormous tip. Right, so I think we're fine. No, we're not. I'm not happy with it. Might be a bit better. Okay. Okay. Okay, let's try again. So, oscilloscope. I said clock is on the outside. Yeah. Data is on the inside. Yeah. And now, let me ground it up. 1, 2. Perfect. Alright. So, now let's connect both the microscope and the power supply. Alright, so power supply on. We had a blimp. And let's prompt to boot. See, both lines went up and we can see already communication there. Alright, the phone is booting up, as you can see here. So this is a normal boot behavior, right? And here on the oscilloscope we can see, we can trigger the communication. Right, so this is data and clock, and we can see both the lines pulling down while they communicate. Yeah, so this is great. Just as a proof, I'm gonna also connect the screen, so you're gonna see that the phone will start. Let me pull the camera back. So as I said, this was an interesting repair. I really enjoyed it. Let me turn off the oscilloscope because I don't need it anymore. Disconnect the probes. So this is how an oscilloscope really comes in handy with the repairs. Gonna pause the video for a second and come back, and we're gonna test with the screen. Okay, so better. Let's test it in its case and see if it's also charging. I'm gonna put just the top board alone. It should work, and with its own battery. This is a bit difficult. Okay, let's put the screen. Okay, and let's try to connect also the battery. So battery is connected, screen is connected, power flex is connected, and I'm gonna prompt it to boot using the charger. I'm getting 0.5 amps, 1.1, so the phone is charging. Let me see, because I know it has some bounce face on it. Alright, so there's nothing much to see there, but we can see here the charging sign, and the phone is charging with 2 amps now. So all is good. This was the video. I hope you're gonna enjoy it, and I hope you learn something. Bye.